This is the second part of a Level 2 Functional Skills Maths paper from NCFE. In this part you can use a calculator. Activity 2, Police Workshop. Alice lives in Oldcastle. She is on a community policing course. The ratio of solved to unsolved crimes in Oldcastle is 2 to 9. 1/8 of crimes are solved in the whole of the UK. Alice thinks that a greater proportion of crimes are solved in Oldcastle than in the rest of the UK. Is she correct? Show how you decide. So we've got to compare these two. One is a ratio, the other is a fraction. So we could convert both into ratios or both into fractions. So we're going to compare a ratio with a fraction. We could convert them both into ratios or both into fractions. I'll go with the latter. So we're focusing on solved crimes. So for Oldcastle, that is 2 out of 11. 2 and 9, that makes 11. That's the total. And in the rest of the UK, the whole of the UK, that is 1/8. So we're going to compare these two. Now, we could convert these into fractions with the same denominator. We could convert these into decimals or percentages. I'm going to go with converting them into decimals since we can use a calculator and that's probably the easiest thing to do. So 2 divided by 11 gives us 0.1818 and so on. So 1/8 is recurring. Then 1 divided by 8, that gives us 0.125. So comparing the two together, 181, 125, this is higher. So that was for Oldcastle. Alice thinks that a greater proportion of crimes are solved in Oldcastle than in the rest of the UK. She is correct. So I'm going to say yes. The value of items stolen in Oldcastle has increased by 8% each year. The value of stolen items in 2017 was £1.7 million. What was the value of items stolen in 2019? Since the value has increased each year, that tells us that this is compound increase. So we'd use the same formula that we use for compound interest. So what's the original value? That's the 2017. And that is 1.7 million. So we're just going to keep it as 1.7 for simplicity. And then multiply that by 1 point, because it's increasing, so 1 point, that's 8%. So if you add 0.08 to 1, that is 1.08. That's how we write the 8% on top of the 100%. And that's to the power of, how many years are we talking about? So from 2017 to 2018, that's 1 year. To 2019, that's 2 years. So to the power of 2. And using a calculator, we get 1.98288. That's going to be million, because that's what we input here. So we could write it like that, or 19828. So we know that would be the comma here for the millions. So 1, 2, 3, and then that's the same as the number we have there. So 1,982,880 pounds. Alice attends a workshop about home security. The tutor tells the group about a house burglary. The police found a footprint in the garden. They used a coordinate grid to record where it was. What are the coordinates of the point marked by X? So that's -3, 4. A witness said the suspect is under 5 feet 10 inches tall and has blonde hair. Alice is shown 15 photographs. Alice picks one of the photographs at random. What is the probability that it is of a person who has blonde hair and is under 5 feet 10 inches tall? Give your answer as a fraction and a decimal. So we're focusing on people who have blonde hair. So hair color, that is blonde, and under 5 feet 10 inches tall. So that is this one here. So that's 3. That meets both criteria. So that is 3 out of, how many are there in total? 6 and 4, that's 10, 13, 15. And to convert this into a decimal, 3 divided by 15, which is 0.2. At 20:40, a witness saw the suspect entering the park at gate A. Another witness saw the same person leaving the park through gate B exactly 12 minutes later. The group are given this map of the park. The map has a scale of 1 to 25,000. The distance between gates A and B on the map is 9 centimeters. What was the average speed of the person seen entering and leaving the park? Give your answer in meters per second. So we're looking at gate A and gate B. So that distance is 9 centimeters on the map. And what's that going to be in reality? So we've got the scale being 1 to 25,000. So 9 will be 9 times 25,000. Which is 225,000. That's centimeters. We need to give the answer in meters per second, so we're going to have to convert this into meters. So in 1 meter there are 100 centimeters, just like centi, century, 100 years, or cents in a euro, it's 100 of them. So we're going to divide 225,000 by 100. And that gives us 2,250 meters. So that's the total distance from gate A to gate B. And that was done in 12 minutes. So 12 minutes. We're going to need to convert that into seconds, because again, as I said, we need to work out that speed in meters per second. So 12 minutes, if we multiply by 60, because there are 60 seconds in a minute, it's going to give us 720 seconds. So how many meters per each second? That's the question. So 2250 divided by 720 gives us 3.125. So the answer is 3.125 meters per second. The house had a CCTV camera. The shaded section of the diagram shows the area covered by the camera. Calculate the area covered by the camera. Use pi equals 3.14. So the area of a circle is worked out using this formula, pi r squared. So that will give us the area for the full circle. And then once we've got that, we can divide by 4 to get this quarter, because we've got a right angle here which is 90 degrees, so that tells us this is a quarter, 90 degrees out of the 360. So pi, that is 3.14, the radius is 5 meters, so 5 squared, so 3.14 times 25, which is 78.5 square meters. Now dividing that by 4, we get 19.625. Alice has a digital picture of the burglar from the CCTV camera. The size of the print is 5.5 inches by 3 3/4 inches. Alice enlarges the picture by doubling both the width and the length. She wants to print the enlarged picture into one side of A4 paper. A4 paper is 21 centimeters wide and 29.7 centimeters long. Will the enlarged picture fit into the one side of A4 paper? Show how you decide. Use the conversion 1 inch equals 2.54 centimeters. So we've got the dimensions given to us in inches. So 5.5, if she's going to double that, that's going to be 11. So 2 times 5.5, that gives us 11. So that's 11 inches. To convert that into centimeters, so we've multiplied by 11 to get to 11, so we'll do the same on the other side. So 2.54 times 11 gives us 27.94 centimeters. So now looking at 3 3/4, so doubling that, 2 times 3.75 is 7.5 inches. So again, we're going to do 7.5 times 2.54, which is 19.05 centimeters. Let's compare now with the dimensions of the A4 paper. So that's the width. Compare that to 21 centimeters wide. That's less, so it can fit. The length now, 27.94, which is less than 29.7 centimeters long. So we can say that it will fit. Yes, and we've given the evidence. by showing the working out. Activity 3, volunteering. Sam is a volunteer for CHAT, a charity that supports children. Charities are put into categories according to the amount of money they raise each year. Last year, CHAD raised £569,801. So £569,801. Tick the box next to the category that CHAD is in. Looking at categories, we've got micro, minimum 0, maximum 9,999, small 10,000 to 99,999, medium is 100,000 to 999,999. So that amount we've got fits into this category. This year, CHAD aimed to raise £626,000. The pie chart shows where the funds will come from. So far, CHAD have raised £95,280 from grants. How much more money do they aim to raise from grants this year? So here we have grants with 21%. So 21% of the 626,000 will be grants. So let's just work that out. So 21%, that is 21 out of 100 of the amount, which was 626,000. And that gives us 131,460. So that's the total that will come from grants. They have already raised 95,280. So we're going to take that away from 131,460 pounds. And that gives us 36,180 pounds being the difference. So that's how much more money they aim to raise from grants this year. Sam asked friends and family to sponsor him for a 10-kilometer run. A local business offers to donate 25p for every £10 that Sam raises. In total, Sam raised £2,634.25. This included the money that the business donated. How much did the business donate to Sam? So 25p for every £10. 25p for every £1, that would have been 25%. Whereas 25p for every £10 is going to be 2.5%. How can we also work it out? We can do 25 pence out of how many pence are there in £10? In a pound there are 100, so in £10 it's going to be 1,000. So 25 divided by 1,000 is going to give us 0.025, which is 2.5%. So the £2,634.25 includes this 2.5% increase. So if we are to show it here, 100% amount would be this one that we're trying to work out, and add to that 2.5%. So all together this is going to be 102.5%, which is, in terms of money, £2,634.25. So what we can do is work out what's 1% worth and then multiply it by 100 to get this amount that we are after. So 2634.25 divided by 102.5, and that gives us 25.7. So that's what 1% is equal to. £25.70 is 1%. What about 100%? Because that's what we need. So we're going to do 25.7 times 100, which gives us £2,570. So that's how much money Sam raised before the donation from the business. So if we do now 2,634.25, take away 2,570, it gives us the difference. Which is £64.25. CHAD are sending a letter to supporters. They have asked for volunteers to put the letters into envelopes. 8 people volunteer to help. Each person works at the same rate. It takes them 480 minutes to complete the task. How many minutes would the task have taken 12 people if each person worked at the same rate? So 8 people, it takes them 480 minutes. How many minutes would it take 12 people to complete the same task? So again, we're looking at inverse proportion here. So what we do to get from 8 to 12, we'll do the inverse over here. So 8 times what gives us 12? And we can do that by going 12 divided by 8, which is 1.5. So now we're going to divide by 1.5 here. So 480 divided by 1.5 gives us 320. So that's how many minutes? 320 minutes. Some people donate to CHAD by giving a one-off donation. The table below shows the one-off donations made last year. Other people donate by paying regular amounts. Last year, CHAD had 150 of these regular donors who donated £7,500 in total. Sam works out an estimate for the mean of the one-off donations last year. He compares this with the mean of the regular donors last year. Sam says, the mean amount donated last year was higher for the one-off donors than for the regular donors. Is Sam correct? Show how you decide. So we've got the regular donors who donated 7,500. It's 150 of them. So what we're going to do is 7,500 divided by 150. So it gives us on average how much each of them donated. And that gives us £50. Now let's look at the one-off donors. We've got these ranges here, so we're going to have to find the midpoints. So between 0 and 20, it's going to be 10. So we're going to multiply that by 48, which gives us 480. Then we've got between 20 and 40, that's 30. Multiply that by 146, which is 4,380. Between 40 and 60 we have 50 times 74 is 3,700. Between 60 and 80 we have 70 times 32 gives us 2,240. So adding all of these together gives us 10,800. So dividing that by the frequency, which is the total number of donors in this case, that is 300. So 10,800 divided by 300 gives us £36 on average. So these are the regular donors and these are the one-off ones. Sam says the mean amount donated last year was higher for the one-off donors than it was for the regular donors. Is that correct? No, it's not, because for the one-off ones that's lower, 36. So we're going to say no. And we've shown the working out. Kay and Mo are employed by CAJD as fundraisers. They are given targets. Kay must raise funds of at least 3 2/5 times her salary. Mo must raise funds of at least 10/3 times his salary. Which is larger, 3 2/5 or 10/3? Show how you decide. There are many different ways we could work this out in. What I'm going to do, since we can use a calculator, so comparing 3 2/5, so that is 3 whole ones already, plus the 2/5. So 2/5 as a decimal, so 2 divided by 5, using a calculator, that is 0.4. So 3 and 0.4 gives us 3.4. Now 10/3. Again with a calculator, 10 divided by 3, that gives us 3.333 and so on. So 3 is recurring. So 3.4 is higher. So that's why we're going to say 3 2/5 is higher. Activity 4, selling cars. Emma sells cars. The original price of a car was £15,400. Its sale price is £13,500. Calculate the percentage discount. Give your answer to one decimal place. So from the 100% amount, which was £15,400, it's gone to £13,500. So the difference is £1,900. So 1,900 out of the original price, which was 15,400. Again with a calculator, 1,900 divided by 15,400 gives us 0.12337 and so on. Now that's as a decimal. As a percentage, that is going to be 12.337. In other words, we've just multiplied by 100. We've got to give our answer to one decimal place. So we're only going to have one digit after the decimal point. So that's going to be the cutoff point. Now looking at the next digit on the right, that's a 3. So we're going to keep this one as a 3 as well. So rounding down to 12.3%. Emma also buys cars. Bill wants to sell his old car. The car is 3 years old and in good condition. Emma uses a formula to work out the price that she will pay for Bill's car. P is equal to 12,000 times C times 0.75 to the power of T, where P is the price that she will pay in pounds, T is the age of the car in years, C is the condition of the used car according to this table. The scatter diagram below shows the prices paid online for the same model of the car in good condition. How much more would Bill expect to get if he sells his car online instead of selling to Emma? Let's see how much he will sell it to Emma for. So let's use the formula. We've got price, so 12,000 times C is the condition, so condition was good. So we're going to put 0.9 times 0.75 to the power of T, which is the age of the car in years, and that's 3 in this case. So inputting this into the calculator, we get £4,556 and 25 pence. Now we need to look at the prices online. We'll draw a line of best fit to help us figure this out. So trying to keep equal distance between the points on both sides. So roughly the age of the car was 3 years, so that's the point here. So now that's between 8,000 and 10,000. We've got 5 divisions, so this must be 8,800, so going up 400 each time. So 8,400, 8,800, 9,200, 9,600, 10,000. So that works. So 8,800. So 8,800, if we take away how much Emma will pay, which is 4,556 and 25 pence, gives us £4,243 and 75 pence. So that's how much more. Bill sees a new car he likes. The car's fuel consumption is 16 kilometers per litre. Bill drives a total of 45 miles each day. Fuel costs 136.9 pence per litre. Work out the total cost of fuel Bill would use each day in his car. Give your answer in pounds and to the nearest penny. Use this conversion graph to help you. So we've got fuel consumption 16 kilometers per litre, and then we've got 45 miles each day. So let's convert the kilometers into miles to help us work out the rest. So 16 kilometers, that is between 10 and 20, so 12, 14, 16 is going to be here. So that is 10 miles. So that's 10 miles per litre. So he drives a total of 45 miles each day. So how many litres would that be? So 10 miles per litre, so 45 divided by 10 gives us 4.5 litres. That costs 136.9 pence per litre. So 4.5 times 136.9 gives us 616.05 pence, because we import pence here. Now we've got to give our answer in pounds to the nearest penny. So that is going to be dividing this by 100, because there are 100 pence in a pound. So this is £6 and 16 pence, because that's a 0, so that means we've got to round down. So £6 and 16 pence. Emma employs Hans. She pays Hans a bonus when he sells a car. The bonus is 1.5% of the price of the car. The available makes of cars are, so we've got makes from A to H with the prices. How many cars would Hans have to sell at the model price to get a bonus of at least £7,500? You must show your working. So we've got these different makes of cars, and we're given the bonus, which is 1.5%. Modal price, so that is looking at the mode. And what's the most common price in here? So the one that repeats itself mostly. So we've got 15,800, 15,800, 15,800. So it's 3 of them, whereas the rest don't repeat themselves. So we're going to use 15,800 and working out 1.5% of that. So 1.5 out of 100, that is, of the amount, which is 15,800. So 1.5 divided by 100 times 50,800, that is 237. So that is the bonus, £237. So how many cars would you need to sell to make 7,500? So 7,500 divided by 237 gives us 31.6455 and so on. So we can't say 31 cars because that wouldn't make 7,500, but we need to say 32 cars, because although it might be a little bit over, it meets this criteria, which is £7,500. So we're going to say 32 cars, because of course you can't have 31.64 cars or something. And this is the end of the paper.